And we're back once again. We're going to start talking about additional identities where we go from a couple products. So like when you have sine times cosine or cosine sine, cosine cosine, sine cosine, or sine sine, and turn them into sum or differences. So I'm going to get started so we can get you guys moving. Okay, first one. First thing I want to think about right away is, okay, I have a sine and a sine. So get your formula sheets out, look at my formulas, and which one am I going to use? Looking at this, I can see that I have a sine and a sine. So I'm going to find my sine and sine right there. So I'm going to have half cosine, so half times cosine a minus b minus cosine a plus b. Now, a lot of you are looking at this and thinking, what is this 10? What is this 10 for? Well, with that 10, you can just bring that 10 straight down and work, you just work with it. So that's going to, it's like a constant multiplier. It's just there. It's going to change once we put that half in there. So let's see where it takes us. So right away, I'm going to put parentheses around. That's why I have 1/2 cosine a minus b, which I'm going to identify my a as this, and my b is 3x. So just to skip a few steps and save some time, I'm going to have cosine of, put my parentheses, a minus b. And then next I have cosine a, I did it again, cosine a, which is 5x plus 3x. Okay, and if you read the question, notice it says, then simplify. So we can simplify because we have a bunch of like terms of here, 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 and here. So we want to simplify, or even this up here, any terms that we can. So now we have 5, that's an ugly looking 5. We have 5 times cosine of 2x minus cosine of 2x. What's interesting now is we see that we have a like term right here and here. Well, anytime you have two like terms, when you subtract a term from another term, you have 0. So now we have 5 times 0, which is equal to 0. All right, so let's keep moving. Okay, next one. Once again, first thing I want to look for is, okay, I have a cosine and a sine. So now I'm going to go over here, look at my formula sheet. Okay, let's see, I have a, what did I say, cosine and sine. So I'm going to look for a cosine and sine right there. So there's the formula I want to use. Now I want to identify my A and my B. Once I have my A and B identified, it's just a matter of plugging in the numbers that you have. So I'm going to put in, or I'm going to write down 1/2 times sine A, we have A plus B, so 3 pi plus pi. And then we have minus sine 3 pi minus pi. Okay, so like I said, we're just using that formula right there. Okay, so once again, we're just going to keep simplifying. So this is going to be equal to 1/2. Well, we have a set of like terms right here. So we have 1/2 times sine 4 pi minus sine of 2 pi. And a lot of you are thinking, well, sine of 4 pi, if I think about my unit circle, is just going around the circle 1 time, 2 times. Well, that point, or I should say this point, right there is just 1, 0. So sine is 0 at that point. So we have 1/2 times 0 minus, same thing, 2 pi. Sine of 2 pi is 0 once again on the unit circle. So 0, that looks like 6, so I'm going to erase that. 0, 0. Okay. And now we have 1/2 times 0, which is just 0. Okay, so that would be your answer. Now we're going to be working with sum or difference to product identity. Same idea, so keep that formula sheet handy. Okay, so first thing we want to do is, like I said, is look at the formula sheet. I'm going to pull that over here. We are dealing with a cosine minus a cosine. So I'm going to go over to my sheet, cosine minus a cosine right here. Okay, can't quite see the whole thing, so I'm going to pull it out a little bit further. Cosine minus a cosine. Okay, so the one on the bottom, that's the one we're working with. So if you, when you're working with these problems, I would almost either write these down or have this handy. Now I want to determine what my A and my B are. So I can just plug them in. It's pretty much all it is finding and plugging in what you know. So this is going to be my A, or my alpha in this case is what the Greek symbol they have over here. And my beta is 3x. So alpha is 5x, beta is 3x. So now I'm just going to write, we know this is going to be equal to -2 sine, big parentheses, just so you can fit it all, 5x, which is my alpha, plus my beta, which is 3x, all over 2, multiplied by sine of my alpha, which is, like I said before, 5x, minus my 3x, all over 2. I'm going to just trim down some steps, or I'll just trim some steps down so we can move through this a little bit faster. This is a like term here. So, and also that. Okay, so 5x, and 5x plus 3x, we know is 8x. Okay? So, I'm just going to write, and then, so if this is 8x, and then this is 2x, well, we know that 8 divided by 2 is 4, so I'm just going to write it that way. So -2 sine 4x, and then same thing over here, we have a 2x over 2. So I'm going to write that as just sine x. So it simplifies from 2x and 2, so we turn the 2's. So we're down to just a sine x. Okay, and that's pretty much it. We have a sine multiplying by a sine, so we have our product. Okay. Now let's move on to the next one. Let's keep moving. So this is going to be my answer right here. Move on to the next one. Sine 75. Okay. Once again, we have a difference here. We do not know what either one of these formulas are. So what we're going to do now is, like I said before, we have a sine and a sine, so sine minus sine. Well, let's look at our formula sheet. Sine minus a sine. Right there in kind of the middle. So now we need to identify our A, or our alpha, and our beta. So this would be our alpha. This would be our beta, excuse me. Okay, so now we'll just write our alpha and our beta into our formula. So we have that equals 2 cosine, big parentheses, because we have a lot going on now, 75 degrees plus 75 degrees divided by 2. janitor just went by, or somebody just went by with a vacuum. So sine, and then my alpha is 75 again, minus 75, all over 2. Well, now we can simplify with what we have. So we have 2 cosine, 75 plus 75 is 150. This is 150 divided by 2 is 75. So we have, or 75 over 1, if we simplify that. And then we have sine, 75 minus 75 is just 0. And 0 divided by any number, 0 divided by that 2 is just going to be 0. Well, right away I can tell myself sine of 0. What's sine of 0? Look back at my unit circle. Sine of 0 is right here. Well, we know that's 1, 0. So it's just sine of 0 is 0. So anything times 0 is 0. So it's just going to be 2 cosine 75 times 0 is equal to 0. So that would be your answer simplified. Okay, let's keep moving. Next one. Ooh, look at that. We have a lot going on in this one. There's cotangent x is equal to cosine 3x plus cosine x, all divided by sine 3x minus x, or sine x. Here we're dealing with two different differences. So we want to make those both sums, or not sums, sorry. We want to make those, we have a sum here and a difference here. We want to make those both multiplication. Well, once again, we can go back to our sheet. We're proving cotangent is equal to that. In this case, I'm going to be working with the side that I want to try and get to this over here. Sorry, I needed to get to my cotangent. So I'm looking and I see cosine 3x plus cosine x. Well, I need a cosine plus a cosine, which is right there. And I also need a sine minus a sine. Well, I'm going to write that in a different color so you can tell the difference. A sine minus a sine, right there. Sine minus a sine. Okay, so I'm going to write what that is in red. So we're going to have sine on the bottom and the cosines on top. So I guess I'll keep the cosines on top the same color. So now we know cosine 3x. Well, this is going to be my alpha and my beta. And for the bottom, this is my alpha and this is my beta, which is nice because they're the same thing. Okay, so let's do the top. So we have 2 cosine, and then we're going to have alpha plus beta all over 2. Should have made that division sign a little bit longer. Alpha, like I said, alpha plus beta over 2. And then that's multiplied by cosine of alpha minus beta, which is 3x. 3x minus x over 2. And now I'll do the denominator, which is sine, and so we're going to look at our sine function here. So we have 2 cosine alpha plus beta again, all over 2, and cosine, oh sorry, it should be sine. I was looking at the one right above it. Sine alpha minus beta, which that's an x, that should be minus x over 2. Okay, it looks like there's a lot going on there. Now most of you should be looking and thinking, wait a minute, let's look right here. Notice this whole part of the one term you're dealing with is the same. So that's going to simplify to 1. You could even say, okay, I have 2x, well, that's going to be just cosine 2 cosine x. You could just say it's 2 cosine x over 2 cosine x again. Well, that's the same thing. So that simplifies to 1. So now from there, I'm going to write 1. I'll write 1 over 1. Let's rewrite that so it's a little bit clearer here. So we have 1 over 1 times cosine 3x minus x over 2. Actually, let's simplify that right away so we're not doing more steps than we need to. You guys don't want to sit here and listen to me chatter forever. So 3x minus x is 2x, which is the same thing as just x. And then sine of 3x minus x is just 2x over 2 again, which is just x. So now we have cosine x over sine x. Look at that. That is cotangent. So it's equal to cotangent x. Boom, done. Okay, now we have to evaluate without using a calculator. Okay, a lot of you are thinking, oh man, I don't know what I should do here. I have sine, tangent, and cosine. There's a lot going on. Well, let's just write what we know. Let's figure out what we know first. Well, arc sine. So we know it's arc sine, and this has to be an angle. And so is the arc tangent. The two have to be an angle. So we're going to make, like I said, an angle. Well, if this is our angle, and we know that sine is what? SOHCAHTOA. So opposite over hypotenuse. Oh, look at that. It's going to be one of those 3, 4, 5 angles. If you don't believe me, check the Pythagorean theorem on that. Okay. Now on this side, we have tangent, which is tangent of 2. See that? Which is the same as tangent of 2 over 1. Well, tangent is what? SOHCAHTOA. Opposite over hypotenuse. Or, sorry. Opposite over adjacent. So opposite over your adjacent. 1, 2, square root of 5. Okay. Well, we also know that we have a sine. So this is going to be a sine inverse. That's the same thing here. So this is like sine inverse. This is like tangent inverse. And we're just finding that angle. Once again, like I was saying, we're with a sine inverse and a tan inverse. Well, we're really dealing with cosine here. So this is going to be like our alpha angle minus our beta angle. A lot of you are going like, oh, how do you know that? Well, remember, we're taking the cosine of, this is going to be an angle. That's what arc sine of that means, and then arc tangent of that means. If you were to type this into your calculator, it'll be an angle. So we have two angles that we're finding. Well, really we're dealing with cosine of that angle and that angle. Well, we know that alpha, or this is kind of similar to what we did in just the difference formulas earlier in the chapter, which we know that the difference of cosine alpha minus, or cosine alpha minus beta is cosine alpha cosine beta, or cosine A, cosine B. And then our sines are going to be different, so plus sine alpha sine beta. Now, thinking about this, oh, wait a minute. If I look at my triangles now, I can find my cosine alpha, cosine beta, and sine alpha, sine beta. Well, beta is going to be this triangle, whereas alpha will be this triangle, because this triangle relates to my alpha, and this one relates to my beta. Okay, so I'm going to find my cosine alpha. Cosine alpha of this angle. So alpha is equal to 1/5. So we're going to have cosine alpha is 4/5, because that's the angle we're looking at. And then cosine beta, we have to go to the other side. Cosine beta is equal to what? 1 over the square root of 5, or I'm going to say 1 over the square root of 5, which is equal to, I was going to take a little mark there, okay? 1 over the square root of 5, which is the same as square root of 5 over 5. Okay, so I'm going to put that right in there. 5 over 5 plus, well, my sine alpha, I was already given that right, where was that given? Well, kind of right here, which is 3/5. So I'm going to just write my 3/5, and now my beta, or my sine beta, which is what? 2 over the square root of 5, or I'm going to say, like we did here, 2 times the square root of 5 over 5. So we have, what is that? 2 square root of 5 over 5. Okay, now we just stuttered. Apparently I'm stuttering. Sorry about that. So this is going to be 4 square root of 5 over 25 plus 6 square root of 5 over 25. Well, we have like terms here, so this is going to be 10 square root of 5 over 25, which simplifies down to, I want the pink pen, 2 over 5 square root of 5. Okay. And that would be your answer. Okay, so summary and questions, homework's on the bottom. I will see you tomorrow in class. Have a good